Hello everyone, in this video we are going to see the Chandy-Lamport snapshot algorithm for FIFO channels. In each distributed systems has a number of processes running on the number of different physical servers. These processes communicate with each other via communication channels using text messaging. These processes neither have a shared memory nor a common physical clock, which makes the process of determining the instantaneous global state difficult. The process could record its own local state at a given time, but the messages that are in transit would not be included in the recorded states, and hence the actual state of the system would be incorrect after the time in the transit messages is delivered. Chandy and Lamport were the first to propose the algorithm to capture a consistent global state of a distributed system. The main idea behind the possessed algorithm is that if we know that the messages that we have sent by one process have been received by another, then we can record the global state of the system. Any process in the distributed system can initiate this global state recording algorithm using a special message called marker. This marker transfers the distributed system across all communication channels and causes each process to record its own state. In the end, the state of the entire system is recorded. This algorithm does not interfere with the normal execution of the process. Assumptions of the algorithm. There are finite number of processes in the distributed system that they do not share the memories and clocks. There are finite number of communication channels and there are undirected and FIFO ordered. This exists a communication path between any two processes in the system. On a channel, messages are received in the same order as they are sent. Algorithm. Marker sending a rule for the process P. The process P record its own local state. Next step is for each outgoing channel C from the process P. The process P sends a marker along C before sending any other messages along the C. Marker receiving a rule for process Q. A step is the following steps are: if the process Q has not yet recorded its own local state, then they recorded the state of incoming channels C1 as an empty sequence or null after recording the state of incoming channel C1. The process Q follows the marker sending rule. Next step is if the process queue has already recorded its states, they record the state of incoming channel C1 as the sequence of messages received along the channel C1. So after that the state of queue was recorded and before queue received the marker. So we are going to see the next topic, need of taking the snapshots. The two important points are checkpointing and garbage collection. Checkpointing, it helps in creating checkpoints. If someone application fails, these checkpoints can be reused. Garbage collection, it can be used to remove the object that do not have any reference. It can be used in deadlock and termination detection. It also helpful in other debugging and determine safety points for the distributed database. Deadlock detection, termination of algorithm are some of the use cases, and to find out the current load of a distributed system. The two major problems in determining the global snapshots are: one cannot catch all the process at the same time. The messages that are on the way cannot be seen. These are the major problems in the snapshot algorithms. So we are going to see the next topic, consistent cut. A cut in a space-time diagram is a line joining an arbitrary point on each process lines that slices the time-space diagram into the past and future. A consistent global state corresponds to a cut in which every message received in the past of the cut was sent to the past of the cut. Such a cut is known as the consistent cut. As a consistent cut obeys the causality and the run of the Chandy-Lamport global snapshot algorithm creates a consistent cut.